Hi, and let's have a think about this. We've been doing work with speed, but we have to touch on this whole idea of changing speed or acceleration. So let's have a look and see what's going on. So if we're going to talk about, this is what your task is about telling me how an object moves and showing me using pictures or describing it. But we also have to do some calculations. Now remember, calculations are always about not only giving the answer, but showing how you got there. So please make sure you do that. So we're going to call it describing motion 2, and we're going to try to work out ways of doing it. Now, what we already know. Motion basically is described by the time it takes to do something or the distance. So if we can measure time or distance, we should be able to describe pretty accurately and pretty in much detail how something is moving. Okay, so as it says here, any motion can be described by how long something is moving and how far it moves. So how far it moves is distance, how long it moves is time. Okay, so in some ways, motion is about movement through time. Ah, very clever, isn't it? But if we're doing this, a lot of people describe things straight away about how quickly it moves. In other words, how quickly it covers the distance or how much time it takes to cover the distance. And that is what we call speed. But we also know from experience, like when we're in a car or when we're in a plane traveling somewhere, how the speed is not always the same. So it's not, well, if it's always the same, we could say it's constant. So sometimes it changes. So if it's a non-constant speed, then we have what's called acceleration. Now, acceleration is simply change in speed over the time you're travelling. Okay, so it can be an average acceleration if we look at the whole lot of it, or it can be a very, very short amount of time. Now, one thing I want you to remember is that speed changes when we speed up, or when speed increases, or when speed decreases, like we slow down. So both are acceleration, and that's really important. Now, when you go on to senior physics and later on in your school life, you might learn about positive and negative acceleration. Okay, but that's more about number crunching. For our sake, we're not going to worry about that. All right, calculations. This is the way you're going to be doing it, and this is what I'm going to ask you to do in class. So what we got here is we're saying speed is a measure of how quickly we change our position. In other words, we look at how far we've gone and we divide it by how long it took us. So we can work out these things, and what we've done is strange I put this in here, but we can actually work out these things and we can actually work from there. All right. But then if we think about the change of speed over how long it took us to change that speed, that is a thing called acceleration. So I'm going to be asking you in some of your tasks to do that calculation for me. Now we will give you these formula and the formula for speed and this one for distance in your task. I want you to be able to use the formulas and know which formula to use to get the answer rather than simply memorize the formulas. Right, so let's have a look at what this is. Now we've got a speed times time graph. Okay, and we can see we've got straight lines, which means we've got a constant. In other words, it doesn't change. It stays the same for all those times. So between 0 and 5 seconds, we have the speed increasing at a constant amount each time. Okay, here we've got it staying the same. Here we've got it rising, and it tells us how quickly we can work it out. And here it is changing again. So here, acceleration. Here, acceleration. Here, acceleration. Now, one of the easiest things for you to do when you're doing this is to look at when it changes. So I know I've got something going here and then it suddenly changes. At that point, then it remains unchanged till that point. And then finally, it changes again and remains unchanged till that point where it changes again. So if you break your graph down into these parts, it makes it so much easier to do. Right, I'm just going to take those points away, so they're not permanently on there. And what I'm going to do is we're going to do something else. Now let's have a look at how it's going on. Right, so I want to bring on this thing so I can concentrate. Right, now if I look at the first section, I see the speed changes from 0 at the bottom down here, that's 0, changes from 0 to 5, but it takes 5 seconds. So my difference in speed, so if you like, over here, I can say my acceleration equals the change in speed, which is 5 minus 0 over 5, or 1 metre per second per second. Right, speed is in metres per second, and then we're doing it per second. So it looks strange, but that's the way it goes. Okay, so that's the first one we do. Now let's look at the next one. If the object has a constant speed, like here, between 5 and 15, if it has a constant speed, does that mean it has any acceleration? Well, the speed doesn't change, so the starting speed is 5, the final speed is 5, so the change is 0. So if we've got 0 at the top, we're going to have 0 metres per second, so there is no acceleration. If we then go on to the third stage, right, between 15 and 20, I've just got to take away something first. Just going to get rid of the 0, it's just a bit distracting. All right, so if we take that away, then we see that it changes our acceleration per second. Well, let's do it. Acceleration, this is number 1, number 2. Acceleration this time goes from, it finishes up, reading up the top is 20, minus, what did it start off at? 5. And how long was it? 5 seconds. So won't that be 15 on 5, which equals 3m/s/s. Okay, that's how we do it. Now let's do the final one. It's also a change of speed, but we're not going to worry about the differences. I'm going to fiddle around with this so it doesn't change. Right, let's look at this one. Oop. Keep on pressing the wrong buttons. Right, let's look at the last one. Now the last one, we see we start off at 20 and end up at, looking down here, that would be 2. And our time it takes is 5 seconds. So if I go into that one, people are having problems with my hands today. For number 3, acceleration is starting off at 20. I'm going to use the biggest number. I'm only interested in the difference between these numbers. And it takes 5. So that's 18 on 5, which will be 3.1236, won't it? m/s/s. I hope you've seen these calculations as we go through. So that's how you solve the problems, and that's as hard as the problem is going to get. All right? So when we're doing this, it says here the value of acceleration will have an average for the time period. We're not seeing how it changes second by second or whatever. We're looking at how it changes over that time period. And that's as hard as it's going to get. And that's why I've said down the bottom, that's a little bit more complicated. And later on in life, you might choose to do some more physics and you might see what's going on with it. All right, now let's see how much you've learned. And there is a practice worksheet which you're going to be completing in class. All right, make sure you do this. Make sure you get it sorted out. All right, you're in a big chance in class to ask questions.